Hello, everyone. I was asked to give a talk on how I select my students, which I have rephrased as how I select and train students to be successful in graduate school, which basically in my mind is a talk about how to be a dragon. So let's start. So first, who am I? I'm Samira Khan. I'm an assistant professor at University of Virginia. Currently, I'm a visiting faculty at Google Brain. Previously, I have also worked at CMU, EPFL, Intel, and AMD. My research interest involves building end-to-end systems for emerging technologies. At UVA, I lead the research group Shift Lab. This name is inspired by the term paradigm shift, popularized by Thomas Kuhn at his famous book, The Structure of Scientific Revolutions. I chose this name because I feel that the mission of my group is to make fundamental changes to the future of computing. So what does that even mean? If we look at the current system, we have the CPU where we perform the computation. We have storage where we store persistent data. And in between memory, in between CPU and persistent storage, we have this DRAM where we put or buffer data for faster access. So this has been the computing model for decades. And we architects sometimes mostly focus on the CPU part. So we have made some changes from single core and we moved to multi-core era around 2000. But currently, with the end of Moore's law, we actually have systems which look very different from what we had. So we have these specialized cores. We are investing in how to make these accelerators for very specific domains. Then we also have innovation on the memory side. We have memory with logic. We have persistent memory, which unifies the characteristics of both memory and storage. But that's not just it. We also have smart SSD, where there is some compute very close to SSD. Samsung has already announced their smart SSD, which we could buy. And there is also innovation on the network side. We have smart NIC, which can perform some computation when the data is coming in and out of the servers. So it looks pretty different than what we had. But that's just not it. So these are the innovations on the server side. But then at the edge, we have these billions of edge devices, which in turn actually can have these smart memories or smart SSDs or some innovation in their network stack. So the current system where the computing model is limited to CPU, memory, and storage will radically change as we move forward. And we have found that in our future systems, data bottleneck is something very important we have to solve by placing compute in all these heterogeneous components. So we have to redesign our system by focusing on data movement. What does that will entail? So now we have to figure out where we should put our computation. Should it be in the heterogeneous core, smart memory? Should it be on the edge side? Or should it be performed on the network? So there are many choices. We also have to think about what would be the interface to application. What type of runtime system would we require to provide that data is consistent in this future system? We have to innovate in the architecture side, and we also have to make sure that our technologies are new and innovative. So in order to build the systems in the future, we actually have to build the whole software stack and focus on data movement. In addition to designing the system for the future, my research group also places a strong emphasis on building artifacts, tools, and data sets. So in our group, I try to build real system testing tools. We have FPGA-based frameworks, we have simulators, we have real data sets. So it's very important to actually build these real system tools and artifacts, because that's how we prove that we are making some changes which are practical, and we open source these prototypes so other people can build upon our infrastructure. So now let's get back to the original question: what do I look for in a PhD student? And to be frank, I look for dragons to train. So the single most important advice that I can give is, if you're trying to figure out how to make an impact in this world, uh, you should try to be a dragon. And I will use this very cheesy quote from Game of Thrones that, don't be a sheep, you are a dragon, so be a dragon. So how do you become a dragon? And I will talk about three things today. I will talk about courage, hard work, and obviously you're entering graduate schools to get mentoring, which is very, very important. So first, courage. So many people think that we are going to graduate school for research, like what's the relationship with courage with becoming successful in research or graduate school or in your career? It's actually extremely important. So what we are trying to do is, we are trying to find our own path, and we are trying to make sure that we are just not following others without having our own thoughts or ideas. So we have to be bold, and we have to be courageous, and we have to have a vision that where we want to go. So courage is important, because if I believe that I can do important work and I want to solve important work, only then I will actually try hard to solve those problems. But if I already think that I cannot do important things, then obviously I would not solve any important thing. So if I shoot for the moon, even if I miss, most probably I will land among the stars. So we are trying to be courageous and have this vision, which will actually lead us to success. The second important thing is hard work. So we can be courageous, and we can say that we will do whatever needs to be done to be successful and to have our own path. But that also requires extreme effort. And there is this virtuous cycle that if I know more, I will learn more. If I learn more, I can do more. And once I can do more, there would be just more opportunities. Some of them will actually work out. So if I think that there are two people with exact same ability, and one person manages to work just 1 extra hour day in and day out, what will happen at the end of that person's career? So think about career. It's actually a very long time. We are talking about 20, 30 years. And when someone is doing slightly extra just for just a little bit, but then for a long time, then it's actually will turn out to be a tremendous amount of work over a lifetime. So it's important to be courageous and also work hard to make sure that we reach to our goal. What's the third thing? The third thing is you want to go to a place where you're being mentored to become successful. So as a professor, I would like to facilitate an environment where students learn how to lead. So what I do is I make sure that there is this active group discussion and brainstorming where students feel comfortable to talk about their ideas and talk about the pros and cons of each idea. So I particularly make sure that the students don't become a sound absorber. So, but what I want to make sure that the students, they participate in discussion. And the way I train it is obviously by example. So students need to learn and defend and push back on ideas, but they will learn it from their mentor. So I have to make sure that I stimulate the students right back. So when they talk about an idea, I have to make sure I provide feedback, and I also have to make sure that I listen to them and they are also participating and contributing to the idea. So essentially, I think what I want to make sure that the students are always engaged in brainstorming and they feel comfortable to contribute to the ideas that will essentially lead them to become leaders when they graduate. So these are just not my advices. Actually, these are the advices that I have got from my advisors and other mentors. And I will particularly mention Richard Hamming. Richard Hamming is best known for inventing Hamming code, but he actually won the Turing Award in 1968. He was part of the Manhattan Project, and he also had a long career at Bell Labs. So he used to give this talk, You and Your Research, where he had summarized some of the characteristics that he had seen in his colleagues who were extremely successful in research. And there he actually have mentioned about courage and the importance of working hard and importance of mentoring. So if you want to learn more, I would strongly advise that you take a look at his talk. And I also have the summary of his talk on my website. So with that, I will end here. Good luck to you all. Hopefully you all be successful and you will become leaders in the future. Thank you.